Good morning. Okay, guys. I think we'll spend a bit more time in the trigonometry part, and then we're gonna move on to the next part. Okay, since we're here, so just spend a little more time. But we need to we have other parts to cover. Okay. But anyway, do you have any questions up to this point? Domain range coverage. And I really highly recommend you guys go back to watch those lectures. And when you watch those lectures, don't just watch it, okay? Don't just watch it. You need to have your paper, pencil next to you and pause or stop at different places and work on it, okay? That's really, I highly recommend, which is, following what I explained to you, my own experience with learning this stuff. Okay, do you have any questions about anything up to this point? Anybody says anything on the chat? No? Okay. So that was trig 8. You can see to be able to do trig 8, all of those concepts are needed. Domain and range for all the trig functions and their and the inverse functions, okay? And the making of those inverse functions and the specific domain and range of those inverse functions. So those arcsine, cosine functions. But anyway, when we say sine function and its inverse, it's not very precise because sine function does not have inverse, right? It's specifically created to a special function, that new function, as we have stated. But anyway, without further ado, okay, we have explained the importance of ARD, okay, the ARD, which is permeating the entire process, okay? So the next part I'm going to quickly go over, which is trig 9a. Oops, the font is changed. Okay, trig 9a. Okay, since we mentioned the formula diagram in your calculus 2, there will be a section that requires you to be able to simplify these trig expressions in order to complete the integration, the integration. Okay, for example, when you have sine squared of x, right? So this is about deriving, the importance of deriving. When you have sine squared of x, how do you derive it? How do you derive into something that you can integrate, okay? And that technique is called reducing power, okay? Reducing power. What does that mean? This expression sine squared is considered to have power 1, power 2, okay? Because there's a little square here. We want to reduce it, okay? Want to reduce it to power 1 or less. Okay, so could you guys bring up the formula sheet with you? You know where to find it? I'm going to point to you which formula I'm talking about. On the formula sheet. Everybody? on the formula sheet on the right side, on your right hand side, the double angle formula. Double angle formula. On the double angle formula, there's, okay, so please refer to the formula diagram. Okay, in that diagram, you will see sine square of alpha is equals to 1 minus cosine 2 times alpha divided by 2. Did you find it? These are pretty, these are considered pretty straightforward as you are in, as you move forward to your calculus classes. It is expected that you know these, or at least you can find out very quickly. Okay, and the other formula would be right next to it. Did you find it on the formula sheet? Yes. Did you guys find it? Right, there's these two formula. Okay, these two formula, and there's a couple of, there are a couple of other formula which transform power to reduce the power. Okay, power 2 reduce, and this is power 1. You see, this is power 1. You guys see that? Another form of writing this is this. Okay, this is, you may find this form more okay. Write it in this form. Okay, and the other one, write in this form. Same form, same stuff. Does everybody follow me? Okay, so these two formula, along with 1, 2, 3, 4, 4 other formula. 4 other formula to your left, in the middle 2 boxes, in the middle 2 boxes. Okay. In the middle 2 boxes, do you see them? To the left, there are 4 boxes, 1, 2, 3, 4. Second one and third one. Okay. 4 other boxes. On the formula diagram, Okay, these 6 formula total. Okay, these 6 formula total. You will need in calculus 2, chapter 7, approximately, for your integration, for your integration effort. So here I'm going to just give you some examples of how to use them. And you want, is highly recommended to practice. Okay, so be able to derive those formula, and it's, you know, like I mentioned yesterday, okay, you have videos to watch and practice. It will benefit you immensely because it did benefit me personally. Okay, So without further ado, let's look at trig 9a. Okay, let's look at trig 9a. Trig 9a, for example, the first one. The first one, sine squared of x. How do we reduce the power for sine squared of x? Okay. In the first formula, which this is derived from double angle formula. Okay, this is derived from double angle formula. From the double angle formula, we derive this. And this formula is these two formula are very, very important. It's not only useful for double angle, it also, that's how we derive half angle. Why is that? Look, this is sine squared of alpha. On the other side, this is power 0, and this is power 1. Okay, this is power 1. Do you see that? This is power 1. Okay, and what is that? This is power 0. This is power 0. Okay, so that's reduced to powers 1 or less. Okay, and of course, if power 0, it's that. In the second formula, okay, same thing, power 2, power 0, power 1. Once you get power 1, you just need one more step, or at least at most two more steps to complete the integration. Because you can use the formula, right? You can use the formula. Okay, so that's to give you a, what's to come your way, which is in calculus 2. All right, chapter 7. Okay, quote me if you will. Okay, chapter 7, probably 3.7.3, 7.4, 7.5 on integration techniques. But anyway, with that said and done, look at how we reduce sine squared of x. Alpha, okay, alpha matches x. So on this other side, it's just simply that. Okay, once you do this, okay, I just give you a kind of, this integration will become that integration. Integrate. And there's just one more step. One more step, done. So that's the scenario. Okay, you will see in calculus 2. And for cosine, of course, that's number 2, right? So you can use this formula. And the next one. Okay, but this is not the end of it. The question could get a little bit more complicated. Okay, so for number 1 on trig 9a, on number 2 on trig 9a, because on number 2, this is just a warming up exercise. Okay, so you're gonna have a similar scenario. And then you'll be able to integrate. Just like that. Okay, you don't need to do this now in this class. I'm just showing you, you're going to be doing that in calculus 2. Okay, so that's number 1 and number 2. So let's move forward. Number 3. Okay. When you do these exercises, you really start to understand much better what I talk about, the placeholder, the placeholder idea, the placeholder concept. Okay. Number 3, you have sine squared of 8x. And we also want to reduce the power. So guess which formula we're going to use? We're going to use this one. Right? But in this case, alpha is 8x. See, alpha is 8x. Okay, so on the other side, what do you think it will be? What do you think this will be? This will be 2 times 8x. And that's going to be what? 16x. It's pretty easy, isn't it?
Yeah, it's a lot easy.
It's pretty easy. Okay, so now let's keep going. Number 4. Okay, we have a sine to the power 4x. We still want to reduce power. We still want to reduce power to power 1 or less. How do we do that? And this time, there's no ready-made formula for us. Okay. We have, of course, we still have these. We have the other 4. Right? We still have these 2, and we have the other 4. Okay. And this is how you do it. And you need to be good at this. Now, first of all, we're going to rewrite this. We turn this to square, and we take 1 square outside. Are you writing them down? You need to. If I were you, I would need to do that. Okay. When I, in my college years, when I look at my professor's work on the board, if I don't write it down after 2 or 3 steps, I will be lost. I will not know what he's doing or she's doing. Okay, if you can follow your professor like 10 steps in a row without having to touch your pen or pencil, you are pretty much a genius. Okay, so I have some criteria for you. Okay, so what do we do here? The inside the parentheses, and this part will be replaced. This part will be replaced, okay, using that formula. So you're gonna get over here, that replacement, and of course this is x. To make it better, you can make it a bracket. That substitution. This is the first substitution. Okay, these 2 formula actually is more often used than the other 4, but the other 4 are also used. They are also used. Okay. And next, we're gonna square the half, and we're gonna square the parentheses. Okay, so when we square the half, we're gonna get a quarter in front of it. And then we have this guy. of that guy. And then what do? We keep the quarter. Okay, you can see why I write it this way, because it looks nicer. It looks nicer. If you write you have lots of stuff on the top and you have one number in the bottom, it looks like someone has a very, very big head and very, very tiny little body. It doesn't look very nice. I mean, it's okay, it's okay, but it just, when we write things, we also try to take care of the aesthetic aspect of our writing. In other words, you make it look nice, make it look, pretty. Does that make sense? Don't underestimate this effect. Don't underestimate this effect. When we see performing arts, everything performed on stage is beautiful, isn't it? Every little detail is attended, from the dress, performers, outward looking. They're all taken care of. And the matter of fact is, when you show a piece of beautiful, nice work to any professor, it delights her or delights him. The chance of you getting more points is much increased. Do you agree with me? It's just a human nature. It's just human nature. I don't mean that your professor is biased or not. Every one of us try to be unbiased. But when you make your work easy to read, easy to identify mistake or correctness, it just makes it very pleasant. Okay, this is so-called what I say on my bookcase is that do to others as you would have them do to you. Okay, when I look up, I have that in front on my bookcase. You know where that come from, right? Do to others as you would have them do to you. Right? If you look at someone's work, you want it to be nice, right? And so is everyone else. So is everyone else. Okay. Now, we're going to open this parentheses. To open this parentheses, I'm going to quote another formula for you. It's a minus b squared. What would that be? It's a squared minus 2ab. Yes, you learned this in elementary algebra. And you're going to use this very often. Okay, the plus and minus. Okay, if this is plus minus, and this is going to be plus minus. Okay, so we're going to apply this formula, one of it, to that. And what are we getting? A is 1. B is a cosine 2x. A is 1. B is a cosine 2x. So here you're going to get 1. 1 squared is 1 minus 2 times the cosine 2x plus cosine square 2x. You can see this expression blossomed, right? Bloomed into more pieces of flower buds. Okay, so what do? So next I'm going to use a bracket. I'm going to put this over here. I'm going to show you exactly what I do. Power 0, power 1. So these two terms are done. These two terms are done. And only this term needs to be done. Need to be more work. Okay, there need to be more work because this has a power 2. And how do we reduce that power? This guy. This guy. The power here is 2. the alpha is 2x. So when I replace this, I need to know alpha is 2x. Alpha is 2x. So if alpha is 2x, this will make a 4x. Does everybody follow? Does everybody follow? Everybody? Okay. The next part is reducing. Okay, because if you integrate this form, it's going to be even more complicated. You don't want to simplify that. Okay, so it's better you simplify this before you do the integration. How do we do that? Common denominator. Common denominator. When did you learn common denominator? When did we learn common denominator? Pre-algebra. Okay, pre-algebra. So we're going to make a common denominator. And of course, the common denominator is 2. I'm going to show you some more detailed steps, but these are steps actually are optional. So 1 will turn into 2 over 2. 2 will turn into 4 over 2. Do you see that? Common denominator. Okay, so I'm going to put the notes here. I'm going to put it over here. Okay, so these boxes or the brackets just indicate the formula quoted. Okay, and over here, I'm telling you the make common denominator. Which is 2. Okay, and next, I have a quarter here. There's 3 terms. 3 terms. 1 term, 2 terms, 3 terms. You guys follow me? In these 3 terms, I have a half. I have a half as a common factor. So I'm going to factor that out. I'm going to factor that out. Okay, so all these half are coming out. So half is out. Half is out. So this will be left with 4, and this will left be with 2. Follow me? And what do we get inside? Quarter times half is 1/8. Inside this bracket, we have a parentheses. So we're going to open that parentheses and combining like terms. Okay, we're going to open that parentheses. There's in front of it is 1, and we're going to combine like terms. And 1 plus 2 is 3. 4 times cosine 2x, cosine 4x. They're not like terms, so we have 3 terms. And at this time, you can change it to parentheses if you want, but it's not necessary. And we're done. Now we're done for pre-calculus, but you will not be done for calculus. Okay, I encourage you to learn to write in this form. I encourage you writing in this form instead of this form. Instead of this form. This is what I mean. Very big head and very tiny little body. It doesn't look very nice. Not only it doesn't look very nice, it will make your work in calculus classes very cumbersome. So write this way. I highly recommend you do that. Okay. Most of the textbook, they will not show these 2 steps. These 2 steps usually are skipped. Okay. I have seen lots of reference books. Most of the reference book, they will skip these 2 steps. So when you read them, you really have, when you read a mathematical textbook, you really have to have paper pencil with you because there'll be a lot of missing steps you need to fill in. If you don't fill in those missing steps, you're not going to follow. You're not following. You will be asked, you'll be constantly asking the question, how did they get that? How did they get that? How did they get that? Okay. All right, so these 2 steps, optional. And these steps is also optional. But it's absolutely necessary for you to do this last step correctly. Okay. And all of the rest of the examples, all of the rest, okay, so you have number 4, number 5, number 8, number 9. Okay, do you guys want to try number 5 yourself? Just work on it yourself, or do this all over again. How about you guys do this all over again? So you have the option either do number 4 or number 5. Okay, I'm going to stop the share. Try to do it yourself. Try not to look at the notes if I've taken notes to see if you can do it. Between now and when you take your calculus 2, there's still about a year, right? And you can still practice in between, but the sooner you get over it, the better. The sooner you get over it, because along the way you're enhancing your algebraic skill, and you need those as algebraic skill for your calculus classes. If you're taking calculus in the summer, oh my God, you have to do this. If you take the calculus class in the fall, yes, you have a little more time. But just remember, time and tide wait for no man, and waits for no man too, no woman too. if I tell you, most of these exercises I give you at Trig 9A, Trig 9B, they are from your calculus textbooks. Okay, I did not make them up. I just copied and paste. And of course I typed them on this document. But they're all from your calculus textbook. And a lot of these exercises, I would say, when I was a student, I saw them, I did them. Or this, you know, when I was teaching those classes, and these exercises, they don't seem to go away. They just all of these similar exercises, they're not going to go away. How's it going? You getting it? Okay, I think we're gonna stop here. Okay, just keep on practicing these stuff. And did you realize you can do it? Yes? Do you think you can do it? I'm telling you, you can. I'm sure you can. I'm totally certain you can. You need practice. You just need practice. Okay. So do you want me to do 5, or do you think you can do 5 yourself? Okay. So I'm not going to do 5. Okay. Actually, I want you guys to try number 9. You guys want to have a head start? I wish to mention another formula to you. Use this as some kind of hint. I'm so happy to see you guys working so hard at this, okay? You will, one day when you are in those calculus classes, you look back to this day and say, all that work I did is worthwhile. Only 3-4 years of your life. Maybe shorter for some of you, right? Are you done? Have you finished? Anybody want to show your work? You can send pictures, or you can upload a file. Okay. I have access to the Pronto. Anybody want to share? How's it going? You done? Anybody want to show your work? No? Yes? Come on, guys. How did you do it? You want me to go over this?
Yeah, I feel like I did it wrong.
How did you do it?
So I replaced the sine squared x and the cosine squared x with the formula.
This one?
Yeah, well, I did that one and the other one, and then I multiply them together,
So this is X. And then how about this one?
and then I put that one next to it.
Use this one? Yeah?
Yeah,
And then what?
and then you multiply them together. I already missed a step.
And then what? Then what you did? Okay. Someone shared a photo. Someone shared a photo. So I'm gonna stop here. Let's look at the photo. Thank you, Kyle. I don't know about you. Usually when I was a student, I like to, I enjoy this part of work. Hold on. Where's my pronto? Come on. Okay, it's coming. And I feel I always learn something from other people. And I also learn something, hopefully you can also learn something from your teacher. Okay. Kyle, you wouldn't mind we share this with the class, do you? Well, you sent it to the class, did you? Okay, thank you.
I'm fine. You can discuss about it.
It's fine. Thank you. Appreciate it. Okay. Thank you very much, Kyle. I really appreciate it. Okay, so this is what he did. You guys see that? I'm going to make it just a little bit larger. Is that a good size? Is that a good size? Right? He did the substitution. Very good. And 1/2 times 1/2 is 1/4. And he FOILed. And he got to this point. Okay, the FOIL part is right. Okay. And then he got to this part. Okay, that's very good. But here, it's a question mark. Okay, so what should have been done? He missed something. I want everybody to grade this with me. From here, okay, to there. something is missing. What is missing? What is missing?
There's supposed to be a half in front of the parentheses.
That's right. 1/2 is missing. And of course, the consequence is, okay, definitely he's going to get partial credit. He should get partial credit, but it's, you also see how I grade your work. And this is pretty much how any math teacher grade their students' work. We just check step by step, equal sign. You're telling the reader this is the same as, and this is the same as, is the same as, is the same as. And our job is just to verify, okay, or confirm your claim or disapprove your, that's fine. Kyle actually did a very good job. You see the way he writes it? The way he writes it is a, I like to comment on the way he writes it. Even though he did it correctly, 100%. But the way he show his work is very, very nice. Okay. For that, you make the reader very easy to read your work, very easy to identify mistake, very easy to make the corrections. It's just, it's a pleasant experience to read a piece of work like this, and I can help. And I don't have to look for things all over the pages. Okay, so the presentation is very nice. Okay. So now we've come to this point. However, from this step, when you multiply these, of course, he did the FOIL. That's not a problem. But he could have also used another formula, which I'm going to indicate. Okay, after, have you guys taken notes? Have you guys taken notes on this part? Okay, so I'm gonna show you my version of doing this, and I'm also going to show you another method. I hope that will enlighten. Okay, thank you for sharing. Okay, so here I get 1/4. We all saw that, right? When we multiply these two, in my eyes, okay, I see 1 minus cosine 2x, 1 plus cosine x. In my eyes, I see a minus b multiply a plus b. A special formula we learned in what? Elementary algebra. Very, very useful. Very, very useful. Okay, so this part to me, okay, it's going to turn into 1 squared cosine squared. 1 squared is 1. That's the formula I used. And next step, I have a quarter. Okay, and I'm going to substitute cosine 2x, and this will turn into 1/2. 1 plus cosine 4x. Okay, so I'm almost there. I'm almost there. Okay, and then I work with the common denominator. Sorry about that. Okay, so I'm gonna put the form. You don't have to do this really for me. I'm just. These notes are typically for you. Okay, and then you find common denominator. Two over two. And then it comes out. Right? It's a quarter. Now the quarter becomes what? 1/8. Inside the parentheses, it's just 2 minus what? This guy. If you want to keep the bracket, you could. We just add them one more step. Okay? You follow me? And then one more step. 1/8. Since I'm writing it this way, I probably just write it this way. Okay, so make it easier for you guys to read. Okay, factored out the half. So now 1/8. You open up the parentheses. You do the subtraction. So this is going to be subtraction. And now it's going to be 1. And inside the parentheses. So that's that. I like to give you some feedback about assessing yourself. If you find this difficult, you really need more algebra. You really need algebra. You really need to derive some more. If you find it is not too hard, you still need algebra though, because this is not a considered very difficult algebra. This is not considered very difficult algebra. Okay, and I also promise you, I'm going to show you another way, and I will. Okay, I'm going to show you another way. There's so many ways to do algebra. Almost for every question, you can do algebra in some different ways. Okay, now this other way. Okay, so I'm going to write it this way. Inside here, I'm going to use this formula. Double angle for sine. So sine x. Okay, so I'm taking this formula. Okay, I'm taking this formula. And then I manipulate it. And sine alpha, cosine alpha is equals to half of sine 2 alpha. So I'm going to use this. Okay, in here. So the squared is still there, but alpha turned into x. So over here, I'm going to have this guy. And then we have a quarter, and we have sine square x. And then one more step. I plug in this formula. Okay, so my 1/4, that formula, right? My 2x is the alpha, so this is going to be 4x. And I'm done. Different ways. You will find yourself getting better and better at this, has more ideas doing algebra, and you're laying the foundation for your success of calculus class. If you can make yourself more proficient in algebra, deriving, you will be so much at ease. You'll be, I mean, I don't mean it's going to be easy. It's going to be a little easier. It's going to be easier. Calculus is going to be hard in itself. Okay. All right. I think let's see. It's 9:10 right now. Maybe we just do one more using the other formula. Okay. Using the other formula. So this one I'm going to choose this formula. It's a formula to the left of your formula diagram to reduce this guy on number 11. Okay, I actually choose one that's not too hard. Okay, so if you look at the 4 formula on the left of your diagram, which one do you think it would be most relevant? Cosine A times cosine B, right? You guys see that? Then you say, what if I forget the formula? What if you forget the formula, right? And that makes it more important if you derive the formula yourself. So today, I just want to get over this, okay? So you can, if you have derived these formula, okay, that's the beauty of another thing. If you have forgotten any one of these formula on the diagram, and if you have derived it, you actually don't need this diagram. Do you follow me? Because this diagram is more like a crutches, right? They are crutches. But if you have derived all those formula, and you will no longer need that crutch. Okay, so now, so you can just use that formula, which is half cosine 2x plus 4x plus cosine 2x minus 4x. Okay, so one more step, you're done. This will be 6x, and this is going to be 2x. And you can use parentheses. Does everybody follow? You can see that, and in your calculus 2, you will be able to perform the integration and finish it. Okay, so this piece of algebra is necessary. It's necessary. All right, but you still have time to practice, but don't procrastinate too long. Okay, the next part I wish to cover on trigonometry, and then we're going to cut it short. We're not cutting it. We're actually not cutting it short, and we're going to transfer to another topics. Okay, if necessary, we will come back. We will come back. The next topics I want to cover here is because we have been in this context of doing these trigonometry, all of these derivings and analyzing domain and range and all of these different aspects. So I think it'll be most fitting that we continue in that journey. Okay, so let's look at Trig 10a. Okay, Trig 10a. Solve for x. We understand when we do solve for, that's if statement. That's an if statement. Okay. When you see a question like this, for example, I'm going to take a simple example, okay? Sine x equals to half. There are a few elements I want to point out. First of all, okay, the first one is this is, of course, is an if statement. Okay, what does it tell us? What does this mean from the function's perspective? From function's perspective, we basically are told that we have this sine function. We don't know the input. We know the output. You follow me? This if statement meaning that we know the output and we're looking for inputs. And where do we find the inputs? Okay. Wanted is the all possible inputs. The second important element I want you guys to understand that solution must be in domain of sine. Solution must be in domain. Then what is a domain? All real numbers. All real number. These are two very important elements we must consider. Okay, these are the two very important elements we must consider. You should not have any doubt or worries. Oh, is this the sign we know, or this sign is that with the domain which is we truncated? No, no truncation. It's all real numbers. So whenever sign is mentioned without any adjective, without any attachments, any specifics, it always meant that sign we know of, domain all real numbers and range between -1 to 1. It's that ratio. Do you guys follow me? Okay. And all of these questions that we have here on Trig 10a, and that doesn't need to be specifically explained. Their domain is meant the domain we knew, we studied. That's what I meant, that those constricted domain is rarely used. They're rarely used. Okay, they are rarely used. Okay, so with that said and done, how do we approach this? I know you know the answer. I know everybody know the answer by this time. But I want to talk about these two methods. One is from the curve and the other one is from the unit circle to identify. And I want to show you how ARD is at play. Okay, these kind of questions are typically from it's DRA. It's not ARD, it's DRA. Because we know the output. So the question becomes DRA. Right? The question becomes DRA. The reason I talk about this is because what if it's not a special angle? Suppose I'm going to change it to 1/3. What do you do? It is still DRA. It is still DRA. Okay, so your job is not only be able to do the special angles. That's why I said special angle is secondary. ARD is the centerpiece. Okay, ARD is the centerpiece. So now let's look at these two different approaches. Okay, so just forgive me, allow me for just a second. I'm going to find out where's my unit circle. Okay, I'm going to bring back my my little rectangular system. Okay, so I'm not going to use unit circle. You see, I'm not using unit circle. Okay, and of course this output is 3, 1/3. And the other one is the how do we identify? Okay, so think out aloud. Think out aloud. Okay, from the if, from the if statement, I look at the ratio. The ratio is 1/3. It's in the range. Okay, 1/3 is in the range. Why do I mention that? If I have a 3, no solution. Do you follow me? But I have a 1/3. So 1/3 is in the range. If in the range, it's possible to have input for it. So it's possible to have solutions. In fact, we have many, many solutions. So 1/3 is the ratio, right? I know the definition of the ratio of sine, which is the, it's y over hypotenuse, right? Y over r, yes. And this number is positive because next on the D, from the D, I'm going to identify the R. Do you follow me? From the D, I'm going to identify all the possible reference angles with 1/3 for the sine value. Do you follow me? So now, so I have two terminals because sine is a positive in the first and second, right? So 1/3. Okay, so I'm just going to draw these triangles. It could be here. So this is 1, and this is 3. 1/3. You guys need this in Calc 2, okay? You guys need this in Calc 2, okay? And next, it could be the second quadrant. It could be in the second quadrant. What are we doing here? We are identifying, forget about these numbers, okay? Forget these numbers. Forget these numbers. Don't worry about these numbers. So that would be 1 or 3. So from D, we get to R. These are the only two possible reference angles we could have. We cannot possibly have reference angles in the third quadrant or the fourth quadrant because it will be negative, right? It will be negative. Do you guys see that? From D, we get to R. And next, what do? We identify the angles. So DRA, yeah? So since we have these two these two terminals, right? Since we have these two terminals, so how do we identify the angle? This is one angle measurement. Angle measurement. How is the angle measured? Counterclockwise, clockwise, right? I will call this angle theta. It's not a special angle, guys. It's not a special angle. How do you represent it? This point illustrates the reason why we introduce arc sine. Why mathematicians introduce this function after all? This here is the reason. Okay. But we know that arc sine only represent angles that between negative pi over 2 to pi over 2. And this angle is in the first quadrant. Therefore, this theta can be represented. How about the other one? The other one cannot be represented by arc sine because it's outside the range. But how do we get the other angle? The other angle is also measured from standard position, either clockwise or counterclockwise. It doesn't matter. I choose counterclockwise because it's consistent. And the other angle would be what? It will be pi minus theta. You follow me? Now we got our solutions. Now we got our solutions. Now we got our solution. So our solution would be what? Our solution would be arc sine 1/3 plus 2k pi or x is pi minus theta, pi minus this guy, which is theta, plus 2k pi. And you also need to tell the reader what is k, because you introduce a symbol. K is any integer. This is the whole process. If you use this notation, say I'm going to use theta, no problem. You can use theta here. But you need to specify theta. Okay, if you don't specify theta, then you can use the previous notation. Okay, so this is just a minor detail. But you can see the whole process. What did we do? DRA. Did I tell you the beginning of the semester? Trigonometry, it's all about either ARD or DRA. And arc sine takes ratio, produces angle. So next, I'm going to give you a complete version of how to do, the answer. Okay, because I always want to give you that version of decent work. You ready? You pretty much have it. You pretty much have it all, but I just wanted to be better organized. Okay, so this angle is pi minus theta. Is that, anybody has any questions? Did you write it down? Did you write it down? Okay, so I'm going to remove and clear all these mess. And I show you how to show the work. With all of these understanding, showing work is really just a piece of cake. Okay, showing work, but you still need to show nice work. I really highly recommend you guys to take some time to make sure you show nice work. It's essential for your good grades. It's essential for your good grades. Okay, so I'm gonna say solution. Okay, and I would say let theta equals to arc sine 1/3. Okay, then theta, then x is equals to theta plus 2k pi sometimes people like to write it this way. Let me show you this way. Theta plus 2k pi, or pi minus that is 2k pi. This is theta, where k integer. And you're done. If you want to attach a picture, that's not a problem. If you want to attach a picture in your solution with all the drawings, if you want, right? Say I want to attach a picture, right? I want to attach that picture, right? I want to attach that picture. Right, this is 1, this is 3, and this is 1, this is 3. And you can even draw this theta like this here, right? And you can draw and like this, right? And that's a pi minus theta. If you draw these correctly, it's a nice addition. It's a nice addition to your work. But in terms of showing work to your professors, this will be enough. This will be enough. Do you follow me? That's how you show your work. So this is trig 10A. Okay. So I think what I plan to do is that we're gonna, tomorrow is Thursday, right? We're gonna continue to finish up trigonometry. So I'm gonna do a little bit more trigonometry since we're here. And then next week, we're gonna change the topics. We're gonna change a topic. We're gonna change to either, logarithm or solving inequalities and that kind of stuff. But this week, we're gonna focus on, we're gonna, finish up 10A. And of course, your homework will be assigned there. Yesterday, or recently, I give you some homework questions, practicing like rationalizing, and those are from the notes. And I hope you guys to pay attention to and work on those. And I did send you messages that the homework did assign to you, and I hope you guys just keep on practicing. Keep on practicing, okay? The more practice you do in this algebra class, okay, pre-calculus class, a little bit easier you will be for you. I know that you guys, you guys are tough guys. You don't want to be easier, but you want to be better, don't you? You want to be better at this. So that will make your success rate much increased. So without further ado, do you have any questions? Okay, I'm going to be heading to office hours. Okay, if you like, you're more than welcome to come. Otherwise, I'll see you tomorrow. Good job. Very nice participation. Okay, and a very good contribution, Kyle, for upload your work. Okay, that was a good piece of work. Thank you very much. I'll see you guys tomorrow. Oh, there's some chat questions. I'm sorry, I overlooked. Oh, okay. Okay, thank you guys. You guys are so sweet. You guys so sweet. Thank you so much. Okay. I will see you guys tomorrow, if not sooner.